Hello everyone, I'm Alex, team lead from the project Luma Video AI. Before we dive in, let me ask you a quick question. Have you ever tried to find a specific topic in a 2-hour training video? It's so painful, right? Here's the reality. More than 70% of users abandon long video because they cannot navigate them. That's billions in lost revenue across the video industry, and that's what we are solving. And I will show you the problem and why it matters. Then my team walk you through our solution and how we are building it. Luma Video AI is a B2B API platform for AI-powered video intelligence, automatically chapters, smart generation, connect analysis. But first, video platform faces 3 crushing problems. First, production costs don't scale. Video production costs at least $1,000 per minute, plus 3 to 5 hours of editing per hour of content. That's unsustainable. Second, about users are leaving. About 70% of users abandon videos over 20 minutes because there are no navigation, no chapters, no way to find what they need. That's a retention crisis. And here's why this matters. 8.5 billion dollar markets growing at 23% annually. The demand is massive. 85% of education platform need automatically segmentation. 91% of developers prefer APIs over building in-house. So the market is ready. Now let me quickly introduce the team behind Luma Video AI. Our tutor Ben provides overall guidelines. Our BA Roxy gathers the requirements from the stakeholders, creates user stories, and makes sure the logic actually works with the UI we are building. Second, our UI UX designer Sting turns those requirements into real designs, from initial frames to final Figma prototypes, handling all the interaction and edge case. And third, our developers, they assess feasibility, estimate effort, and build everything from front end to back end, APIs to database logic. They also handle testing and make sure we're shipping stable features every sprint. Now let me hand it over to my team member.
Hello everyone, this is New. And so let me introduce how our project is special. So our solution is simple. We build a lightweight AI tool designed to minimize the user effort and maximize the quality of output. So users only provide one short input, and the system automatically handles all the complex steps behind the scenes. So the goal is to reduce friction and help user getting something directly usable. So instead of some raw or unfinished text. So next page. Technically, the system uses React and TypeScript on the front end, Fast API on the back end, and combines LLM reasoning with our customer logic modules. We also use vector search and lightweight caching, and the entire pipeline structure input guided AI reasoning and template driven output to ensure both intelligence and consistent. So architecturally, the system is modular. The front end sends requests through an API gateway, and then which coordinates the logic module, and then the LLM and the vector database. This makes it easy to add features to extend the system in the future. So our key innovation are minimum interactions, stable outputs through the rule-guided AI and modular expandability, and a strong focus on the particular practical useful rather than just building another demo. That's it. Let's hand over to Vinci and Becky for the next talk.
Okay. For this phase, we are focusing on the core essentials that includes user authentication, the main public pages, the dashboard with usage display, API key code strip filling, and basic profile settings. On the product side, we support the key video generation API features, text-to-speech, text-to-video, brand customization, multiple voice styles and segmentation tools like scene detection and keyframe extraction. Autoscope for now are the heavier UI parts and advanced video tools. So we are not including the dashboard modules beyond authentication. No video editing UI, no manual editing tools, and no advanced video effects. The goal is to deliver the core flows first and save the complex UI and editing features for a later phase.
Speaking of the MVP, our minimum viable product delivers a simple but powerful API that helps platform process and understand video content right away. Users can upload large videos, get accurate transcripts, and automatically break long recordings into clear topic-based chapters with titles, summaries, and keywords. The system also includes essentials like secure authentication, API key management, billing, dashboards, and webhook notifications. Altogether, the MVP gives teams a complete out-of-box pipeline that reduces product time and improves navigation for learners and removes the need to build any video AI infrastructures themselves. Next page, please. Yeah. As for our future enhancements, in the next stages, the platform will grow into a much more comprehensive video intelligence suite. We are adding text-to-video generation with customizable branding, real-time progress updates, batch processing, and tools that let users edit or refine AI-generated chapters. Further down the roadmap, we plan to support live stream analysis, multilingual translation with voice cloning, custom model training for enterprises needs, and advanced analytics to reveal content engagement patterns. These enhancements will allow Luma Video AI to evolve into the go-to solution for scalable, intelligent video workflows across the multiple industries. Now I'll pass it to my teammate for our workflow introduction.
Hi, I'm Henry, and I will introduce the SDLC workflow we use in the Luma AI video project and how tasks move through our board. Our project follows the SDLC, which keeps every feature transparent and traceable from initial requirement to final delivery. We follow an agile development approach, meaning that the project moves forward in small iterative steps. Each cycle helps us adapt quickly to changes and deliver improvements continuously. The process starts with planning, where the team breaks the project into manageable tasks and set priorities. These tasks are then added to the sprint backlog in Jira, ready to be picked up by developers. Once development begins, each developer creates a feature branch from develop and works on their assigned tasks. During this phase, we continuously update the Jira task status so the team can see progress in real time. On our board, each task moves through 5 clear stages. The first one is to do, task is ready to start. And then it goes to the next stage, which is in progress, which means active development, including UI logic and API work. And then it goes to the next stage in review. Feature is completed and a pull request is submitted for code review. And then it goes to in testing. After merging into develop, the feature undergoes functional and compatibility tests. And then it goes to the final stage, which is done. All tests pass and acceptance criteria are met. The task is officially completed. This workflow combines iterative agile cycles with practical task tracking, keeping our development, quality control, and the team collaboration clear and manageable. And then Hausen will explain how we plan our sprints, run daily things, and collaborate day to day.
Hi, I'm Hausen, and I will continue by explaining how our sprint structure and collaboration process support efficient teamwork. We follow a disciplined 2-week sprint cycle to keep development predictable and well organized. Every sprint begins with sprint planning, where we define sprint goals, refine backlog, and assign tasks to the team. During the sprint, we hold daily stand-ups to synchronize progress, identify roadblocks, and ensure alignment. At the end of the cycle, we conduct a sprint review, where we present the completed features. This is followed by a retrospective session to discuss what went well and what can be improved. This structure helps us continuously refine our workflow and deliver consistent progress throughout the project. Next slide, please. Thanks. Our collaboration workflow ensures that everyone stays connected and aligned throughout the project. We use Trello for progress tracking and state updates. GitHub supports our development process with structured branching, pull request review, and version control standards. By combining those tools and maintaining clear documentation, we ensure good collaboration between developers, designers, and other stakeholders. Next, Lily will explain how to ensure code quality for our product.
Hello everyone, I'm Lily, and I will briefly explain how we ensure quality in our project. First, before starting any task, we always pull the latest main branch and create our own feature branch. This keeps our work update and avoids conflict. While developing, we self-test our feature and remove any temporary test code before committing. Ensure a clean and reliable code base. When the feature is ready, we open a pull request for the senior developer to review. Only after approval can the code be merged into main. To maintain consistency, we use standardized formatting tools like Isling and Puritier, which enforce clean and error-free code. By following this workflow, updating main, working on a feature branch, self-testing, applying formatting standard, and completing code review, we ensure every change merged into main is stable and high quality. I finished now, so I will now hand over to the tech session for next person. Thank you.
All right, let me give a quick overview of the tech stack we are using for the Luma Video AI project. On the front end, we are building with TypeScript, React, and Vite. TypeScript gives us strong type safety and a better developer experience. React allows to structure the UI into reusable components, and Vite provides extremely fast dev server startup and build times, which help us iterate much faster during the development. For the back end, we are using Node.js with Express. Express keeps our API layer lightweight and flexible, making it easy to define REST endpoints and integrate middleware. Our database is PostgreSQL, chosen for its reliability, strong relational features, and also the JSON support. To interact with the database, we use Prisma as our ORM. Prisma's schema-driven approach gives us type-safe queries and a smooth migration, and it integrates seamlessly with TypeScript. Finally, everything runs inside Docker, which ensures consistent environments across development, testing, and deployment. I will now hand it over to Rebecca for introducing the tools and the pipelines of our project.
So on the collaboration front, we rely on Git and GitHub for version control, and we manage our agile workflow using Jira, specifically for tracking sprints and tasks, while Notion serves as our central hub for knowledge sharing. To maintain high code quality, we use ESLint for static analysis to identify potential bugs and bad patterns. Paired with Prettier, we enforce a consistent coding style across the entire repository. And for our testing strategy, we picked VTest. Given our tech stack is built on Vite, React, and TypeScript, VTest offers a seamless integration compared to other test runners. And lastly, we leverage AI-powered tools like Cursor and Claude to accelerate development and boost overall team productivity. So together, this modern tech stack leverage a unified TypeScript ecosystem to ensure end-to-end type safety and seamless development between the front end and back end. Combined with Docker and a robust quality pipeline, it delivers a high-performance, scalable architecture that significantly boosts developer productivity and code maintainability. And that concludes the presentation on the Luma Video AI, and we're now happy to take any questions.